Hi everyone, thank you so much for joining my session. My name is Alba Rivas. I am a developer advocate here at Salesforce, and today I'm going to talk about how we implemented automated accessibility testing in our sample gallery apps and how you can do the same in your apps to enforce accessibility best practices. Great. So here you have my contact details in case that you want to contact me later. And this is the forward-looking statement slide, which means that as Salesforce is a publicly traded company, purchases should be made based on the functionality that is GA, which is generally available. But don't worry, because today we are going to talk about GA features all the time. Good. So let's start talking about accessibility. At Salesforce, we have a strong commitment towards accessibility best practices. We want to make sure our products are easy to use by people with all abilities. And because of that, we try to follow, to the extent possible, the accessibility best practices that are part of the Section 508 of the Rehabilitation Act and the Web Content Accessibility Guidelines. The Web Content Accessibility Guidelines have two versions, the 2.0 and the 2.1, and they have three levels. Concretely, at the moment, we are targeting version 2.0 and level AA, but we are starting moving towards version 2.1. So we try to enforce accessibility best practices internally, and we try to be transparent with that. So what we do is that we publish a report for each product. These are called ACRs, which is Accessibility Conformance Report. And if you want to take a look at them, you can go to this link here. I'm going to show it to you. Is this page here? And here you have access to all the accessibility conformance reports that are available for our products. There you are going to find the status in what regard to accessibility best practices of all our products, right? Including Trailhead, Heroku, etc., etc., etc. It's very useful. So it's clear that we try to enforce accessibility in our products, but now I'm going to tell you why I decided to give this webinar. So my team owns something called the sample gallery. I don't know if you know it. Just in case you don't know it, this is something that you can access from Trailhead, right? And Trailhead page. And the sample gallery contains a series of applications that we have created to teach developers the best practices to build applications on the Salesforce platform. We have many apps, and some of them use declarative features, as for example Flow or Process Builder. Many of them use code. Some of them use Apex, Lightning Web Components, Visualforce, etc., etc. And well, as I said, we try to always follow the best practices so that these apps serve as an example to other developers. So accessibility is one more best practice that we want to follow. And it happened that we have then evaluated how these apps were following enforcing accessibility best practices until this year. I was the person who tackled that project, and that's the reason I have decided to do this webinar and explain to you how I did it and how you can do the same. Well, so the first thing that I needed to do was to learn accessibility best practices, right? And luckily, there is a Trailhead that the accessibility team at Salesforce has published. And this trail is really cool because there you have modules that are targeted to different kind of roles. For example, we have a module for designers, another module for developers, another module for testers, etc. Right? So if you want to get started with accessibility, I recommend you to go there, this URL here, and learn about those best practices first, because you need to understand that those basic concepts, to be able to fix any issues that your applications may have. Then we decided to give a first step into our accessibility project and implement sa11y. So what is sa11y? sa11y is a set of JavaScript libraries that allows you to write automated accessibility tests in JavaScript. This is great because, well, first you are going to be able to detect if your existing components have issues, accessibility issues, but also you are going to detect in the future if, for example, a change in a component introduces a new accessibility issue. sa11y, indeed, is something that we use internally at Salesforce. This helps us enforce accessibility best practices. This helps us generate those accessibility conformance reports, right? And it's something that we use in, I think, almost all the products. It's open source, so that means that you can use it as well, same as we did in the sample gallery, right? All the code in the sample gallery is open source, so we are always using open source tools. And why sa11y? Well, this is because of the next reason. Accessibility is commonly known as sa11y, and this is because there are 11 letters in the middle. It's a way of shortening it a bit. This is called a numeronym, and the S is just for Salesforce. So Salesforce plus sa11y, sa11y. Great. So sa11y is fantastic. It allows you to detect a good quantity of accessibility issues, but of course there are issues that are not detectable automatically by a machine. This means that sa11y is the first step, or at least it has been for us, but that does not exempt you from having to perform other kinds of accessibility testing, for example, keyboard testing, screen reader testing, etc., etc., etc. We haven't done that yet on the sample gallery apps, but we have plans to do it. So here you can see 3 columns. This is because sa11y includes 3 different modules. The first module is going to help you when you are using Jest to write JavaScript unit tests, right? The second module is going to help you when you use WebDriver IO. And the third module, you can use it for generic JavaScript when you are using generic JavaScript testing and you are not using Jest, neither WebDriver IO. And this is a summary of some of the issues that are supported and some of the issues that are not supported. I mean, not supported, with that I mean that sa11y is able to detect these issues or it is not able to detect them, right? And this is a summary table, not every single detail is covered here. But it's a table that I wanted to show to you so that you get an idea of what happens with sa11y, right? What you can do with sa11y. Great. So now I'm going to show you a demo. I'm going to show you how we install sa11y in our project repo, and I'm going to show you how to write a basic accessibility test and run it. Great. So here we are in VS Code. This is a project I have created using the force project create command. It's a very simple project. The only thing that I have added is a Lightning Web component, this one here, because we want to write a basic accessibility test to ensure that it is following accessibility best practices. So the first thing that we are going to do is to install the sa11y jest module. To do that, you have to write npm install -d because we want to add it as a dev dependency, and then the name of the module. Remember that this is 11, right? It's not sa11y. If you write sa11y, you are not going to find the module. So now npm is downloading the module, is storing it into our local node modules folder, and it's also adding it to our package.json. If we open the package.json file, we are going to see here that sa11y jest has been added as a dev dependency. Why do we use jest? Because it's recommended to write unit tests for Lightning Web Components using jest and the jest plugin that we have developed for it, especially for it in Salesforce, right? Great. So now we need to create a configuration file for sa11y. We need to register a matcher. We could do that in every individual test file that we create, but it's handy to create a configuration file so that that's done for all the tests in every test run, and we don't have to worry about that anymore, right? So for that, I'm going to create here a new file. The name of the file is going to be just sa11y setup.jas, but you can use a different name if you want to. And here I'm going to paste some code that I have already created, in which we are registering that matcher, which is the one that we will need to invoke to ensure that our tests are following accessibility best practices, right? So now I'm going to create a jest config file so that I indicate to the jest configuration that it needs to execute this file at the beginning of each test run. If you were using jest before, you may have that file already created, then you will have to modify it, adding this configuration file. But in my case, I wasn't using jest config before, so I'm going to create it from scratch. The jest configuration file needs to be called jestconfig.js. And in this case, I'm going to add the following code. So what are we doing here? So first, we are importing the configuration that comes in the SFDX LWC jest plugin, which is the plugin that we created to help you test Lightning Web Components with jest. Then we are retrieving this configuration variable, setup files after env, right? And we are pushing the configuration file, the configuration script that we have just created. If you picked a different name, you will have to indicate a different name here. And finally, we are exporting the configuration file with the new setup files after env configuration. So with this, we are ready, and we can use our sa11y matcher in any Lightning Web Component test that we create, right? So what we are going to do is to create a Lightning Web Component test for this component here. This component is very simple. It's a conditional rendering component in which we are showing a piece of markup if this property is true, if the details are visible, right? If I take a look at the JavaScript file, this is super simple. The are details visible property is just an API property that an external component can set from the outside. And we are going to create a test for this component. The fastest way to create a test for a Lightning Web Component is to use a shortcut that we have here, which is this one, create Lightning Web Component test. You indicate which is the directory in which you want to create it. You indicate the Lightning Web component for which you want to create it. And that's it. This is going to create the tests folder, as you can see here, and it's going to create the test file. I'm going to close this as I'm not interested in showing you the files anymore. And we're going to focus now in the Lightning Web Component test. So here, well, I don't know if you are familiar with just test, but what they are described normally by a test suite, right? And what we do is we need, after each method in which we will remove all the HTML elements that have been added to the document body so that we can clean up the virtual DOM for the next test, right? And then we start writing the test. Here, if you create the Lightning Web Component test using this shortcut or using the same command in the Salesforce CLI, a dummy test is going to be created for you. And what we are using behind the scenes is JS DOM. JS DOM is a library that allows you to create a kind of virtual DOM in which texts are going to execute. So we are not really executing the test in Chrome or Firefox or whatever, but in this DOM that is created artificially for you, right? So now what we are going to do is to modify this test. All the tests have a definition. Normally here you explain what you want them to test. So for example, here we are going to test if the component is accessible. Then all the tests have a data creation phase in which we create the element. We indicate which kind of element it is importing its module right here at the top, and the create element is a function that you can import from LWC. You append the element to the child. This is the when part. I like this naming convention when you do divide the test in 3 different parts. And then you have the then part. Well, when you execute whatever action, in this case is when you add the component to the DOM, and then is the section in which you do your assertions, right? To check that the component expected to be whatever, and now it's whatever, right? So this is a dummy assertion, but what we are going to do is to use the matcher that we registered here, right? The Sally matcher that we registered in our Sally configuration file. This matcher is called to be accessible, is already available for you in every test file because this configuration that we did at the beginning. And what we want to be accessible, well, it could be the document, but in this case, what we are going to test is each individual element because we want to be more concrete, right? We want to test a smaller portion of the HTML code. Okay, so 2 more things are missing here. So first of all, think about this component. Here, if I execute the test as it is, what happens is that by default this property is false, and by default all this HTML code is not going to be visible. In this simple example, it's just a paragraph. It shouldn't have any accessibility issues, but normally you will have more complex markup there, right? So what we need to do is to make sure that we are testing all the possible configurations of the component and all the possible markup that may be visible in that component. So in this case, what we are going to do is to go back to our test, and we are going to open the details section, so that when we execute the to be accessible matcher, all the markup, all the visible markup is evaluated, because only the visible markup is going to be evaluated, right? And there is something else. This call here needs to be executed asynchronous, right? Here you have two options. You can use a promise or you can use async await. If you want to use a promise, what we do is that we return a promise.resolve .then, and then we write an arrow function that returns the whatever the matcher returns, right? This is a way to do it, one of the ways to do it. So now I'm going to run this test and we are going to see the results. A very easy way to run this test is clicking here. And we are going to see if the test passes. Yeah, so this passed successfully. That means that my component is following the accessibility best practices that Sally is able to detect, right? If you want to use async await, then what you do is you write here async, and here instead of all this promise thing, we write await, and it's the same, right? If I run the test, it's going to work in a similar way. Fantastic. So this is all that I wanted to show you, and let's go back to the presentation. Great. So I hope that you enjoyed the demo. Now I'm going to give you some best practices to follow while writing accessibility tests. The first one, bear in mind that you need to test for different DOM configurations. In our example, we just had a section that could be open or closed, but it may happen that you have a component with many sections, and that depending on some properties, the component may be showing some of the sections, and depending on the different properties, it may be showing other different sections in it. You have to bear that in mind, and probably you will have to write more than one component to test for all the different configurations. This is true also for states. It may happen that you have an HTML element that, depending on the state of the component, has a different CSS class or a different attribute specified, for example, a section that may be open or closed, etc. Right? In that case, you also need to write different accessibility tests for each state the component may encounter. I have a third recommendation, which is to remember that when using the plugin that we have for Jest tests in LWC, you are not really using the lining-based components implementation, the real one, but you are using some lining stubs. Is the stubs here. I'm going to show you them in the repo. So what happens with these stubs? These stubs are not real, the real implementation of base components. It's a fake implementation. If we take a look, for example, at the accordion one, when you are using a lining accordion in your Jest test, you are really using this template here. All the templates for the stubs just show wherever you pass in directly in the template. So for example, if you are passing content to a lining accordion section, that lining accordion section is going to always render the content that you have passed in. That means that you don't have to test with now this section is open and now this section is open, same as it happens with your custom code. No, because here really the lining accordion implementation is a dummy implementation in which we don't do anything with the properties that we pass in. Okay, that's something to remember. for general jest testing, but also for accessibility testing. And finally, my fourth recommendation is that you try to follow the black box testing approach when possible. This testing approach explains that, for example, if you have a parent component and a child component, two custom components that you have created, you should test for the behavior of the child component in the child component and for the behavior of the parent component in the parent component. You must decouple them, right? Normally, mocks, stubs, and spies are going to help you with that kind of testing, right? Great. So I started this webinar talking about how we implemented sa11y in all our sample apps. After implementing sa11y and writing accessibility tests for all our components, making sure that all the different DOM configurations and states were being tested, these are the issues we found, right? As you can see, there were not many issues. The app that had more issues was Salesforce 12WC, but it happened that it was the same issue repeated 22 times. So it was not a big deal. And indeed, it was an issue a single component had, a single child component had, and that way we realized that we were not following the black box testing approach correctly, because that issue was being inherited by other 22 components that were using the child component. Now you understand the importance of following this black box testing approach, right? And then the other components, the other apps had like 1, 2, or 0. Not a big deal. The reason for that is mainly that we were making extensive usage of Lightning-based components, and the Lightning-based components team tried to follow accessibility best practices to the extent possible, so they are good in what regard to accessibility. And also we were using SLDS, the Lightning Design System, which also enforces accessibility best practices. If you want to take a look at the code, I leave you here the different branches in which we worked. All of them are public, right? All our code is public. And this is a summary of all the different issues that I found. For example, we had an iframe with no title, we have a heading with no content. What we did to fix it was to add by default title. We had an image which had no alt text. These are the kind of accessibility issues that you are going to learn about in those Trailhead modules I mentioned at the beginning. We had an unordered list tag that was containing tags which were not allowed. There weren't a list, a script, or template tags. And finally, we had some headings that were increasing by more than one level. For example, instead of doing H1, H2, H3, we were doing from H1 to H3, and that's a bad accessibility practice. Here, I open one of the pull requests. For example, this is the pull request in which we fix the problem with the iframe. Indeed, this is the one in Salesforce 12WC, the one that was repeated 22 times because we weren't doing a good implementation of black box testing. And this is how we fix the no heading content one. And what we did was to add a default title, so that always that component has a title, no matter if you forget to add it. Great. So as I mentioned at the beginning of the talk, this is the first step. There are more steps that you need to perform if you want to ensure that you are following accessibility best practices. But it's a great first step for many reasons. First, it's going to give you an idea of how much do your apps enforce accessibility best practices. In our case, we didn't find many issues, and I think it's because we are making the extensive usage of base components and landing design system. Second reason is that once you implement sa11y, your accessibility tests are going to run as part of your CI jobs. Well, I hope that you have some CI jobs set up. If you don't, you can set up them once you include sa11y, right? And most importantly, we learned accessibility best practices. These are the resources for the talk. First, you have the sample gallery resource. You have also here the trailhead trail. They get started with web accessibility. Here I leave you the link to the sa11y repo. Here I leave you a blog post I wrote on the developer site. Is a summary more or less of what we have seen in this talk, and you have some code examples, so I recommend you to take a look at this. Then on Medium there is another blog that the UX team maintains, in which they have some blogs related to accessibility. And in the Lightning Design System Guide, there is a full section about accessibility, explaining how do we enforce accessibility in the Lightning Design System and how you can continue enforcing that those accessibility best practices while using the Lightning Design System on your own. Finally, I leave you here some Twitter handles. If you are going to implement sa11y, please tweet about it and you can mention myself. Sorry, this is wrong. It's Alba SFDC. Okay. You can mention Salesforce developers, or you can mention Salesforce UX or Salesforce Ally, which is the sa11y username for Twitter. Right? So again, thank you so much for joining the session. I hope that you like it. If you enjoy it, please remember to share it, or you can drop me a message on Twitter or whatever if you have questions the same. And that's all. Thank you so much and happy coding!